All right, so today we're going to be doing a tutorial on the International System of Units, or SI system. So our question is, why do we need to be able to measure things? And we have lots of things that we want to measure in our lives, and so we need a system to do that. So let's suppose a hypothetical. Suppose you wanted to measure a 2 by 4 for building a house. Now, those numbers 2 by 4 by themselves don't mean anything. If you go to a hardware store and say, I need this as this 2 by 4, they don't know if you mean something that is 2 inches or 2 feet. So I could say a board is 350 long, 350 what? And so units by themselves don't make sense. I could say a board is a meter long. So numbers and units by themselves don't make sense unless you give some context. To make sense, all measurements need two things. They need first a number and a unit. So whenever you're making your answers, especially in science and math, it's incredibly important that you put in the number and the unit. So if I put, 300, well, what does 300 mean? Do I mean 300 feet, 300 yards? I mean 300 meters. So in putting that, I give us a lot better idea of what I'm looking at, what I'm trying to describe in my investigation. Now, estimation is a form of measurement. It's using your knowledge of something similar in size or amount to determine the size of a new object. You can kind of think of it like this game right here, where you try to guess the number of gummy bears or gumballs in a jar. So it helps us to make rough measurements of an object. Useful, usually when you are in a hurry, and exact numbers aren't necessarily required. I'd say I estimate the person is, 6 feet tall. He may be 5'11", he may be 6'2", but he's roughly 6 feet tall. But when it comes to science, the ones that you should really focus on is precision and accuracy. Because in science, small differences make big changes in an experiment. So precision is a description of how close measurements are to one another. And accuracy is comparing your measurement to the actual or accepted value. And so the more precise you are, the more accurate you are, the better your data will be. Now, why use the SI system? We've been learning feet and inches and yards for most of your life. Why use the SI system? Well, in the US, we use the English or standard system, and most of the rest of the world uses the metric or SI system. We're one of the few countries in the world that actually use this English system anymore. And more, you're seeing kind of a shift of this outside of, basic things that we use every day. A lot of things are being made in this SI system as we're becoming more of a global economy, having to deal with other countries for shipping, manufacturing needs. And so understanding this SI system is really important to you in the future, because in more likelihood, more things and more things you will see become SI or metric. So the SI system, or International System in Units, is the form of measurement typically used by scientists. And so for our purposes in our class, we will exclusively use the SI system. Understanding the system is very important when we get into discussing, different formulas, the volumes, and things like that. Scientists use the SI system worldwide because the measurements are easily understood by all scientists. It wouldn't be very good to have a system of units that not everyone understands, and it can cause issues on projects and things like that. Measurements are actually a lot easier to convert than the English system. The SI system is so easy. So we have basic types of measurements we're going to discuss today. Length, volume, maths. Length is the measures distance between objects. Volume measures the amount of space something takes up. And mass measures the amount of matter in an object. So in the SI system, the basic units for this are going to be the meter, the gram for mass, the liter for liquid, and you're probably familiar with this if you drink soda or anything like that. You get a 2 liter of whatever. And temperature is done in Celsius. So let's take another look at this. There are other measurements that we'll discuss. So time is the same. Temperature, density, pH, all these fall under the SI system. So all measurement systems have standards, and these give you a little bit of a comparison between the English system that we use in America and the SI system that's used predominantly around the world. So yards are like meters, inches are like centimeters, ounces are like grams, pounds are like kilograms, quarts are like liters, Fahrenheit is like Celsius and Kelvin, and time is the same. So in the English system, you have to remember so many different numbers for conversion. 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile, 16 ounces in a pound, 4 quarts to a gallon. In the SI system, you only have to remember one number, and that is 10. The entire SI system is based on the number 10, which makes conversions exceedingly simple. So this system works with any SI measurement. This is the prefix system: kilo, hecto, deca, deci, centa, milli. And so if you think of it like a number line, which you've probably seen in math before, this is like 0, and this is your positive side of the number line, and that's poorly drawn, but there's your negative side of the number line. As you're basically with this, all I'm doing is moving a decimal point. So as I add a 0, I'm going higher in value. And so that's my positive side, my deca, hecto, kilo. And as I'm moving away from the 0, I'm moving my decimal point, and I have deci, centa, milli. So it's the same system whether you are measuring length, mass, or volume. It's all the same system as far as these prefixes. And so it makes it really easy. It makes it really easy. So if I said, a kilogram, that means 1,000 grams. Okay. If I say a kilometer, that means 1,000 meters. You don't have to remember all these different little things. So it works for all types of measurements. If you're measuring, mass, then it's a gram, centigram, milligram. If you're measuring length, kilometer, decameter. Volume, deciliter, hectoliter. Just this prefix system makes things so much easier. So the first part of the term, right here, the centa, indicates the amount. The second part of the term, right here, the gram, indicates the type of measurement. So here we have the amount, and here we have the type of measurement. Very simple. The type of measurement is going to tell us what we're measuring, if it's length, volume, what mass, the amount. It's going to tell us how much we relatively have. So it's a really simple system. Once you practice with it, it's very simple. Now, probably what your biggest thing is, like, how do I convert units? Unlike the English system, converting in the SI system is very easy. For example, in the English system, if you wanted to know how many inches into miles was, what would you do? Well, you'd take the number of miles, 2, multiply it by the number of feet in a mile, 5,280, then multiply that by the number of inches in a foot, 12, until you got 126,720 inches in 2 miles. That's quite a lot of work. But in the SI system, there's very little work. It's much easier. For example, if I wanted to know how many centimeters were in 3 meters, what would I do? Well, 3 meters, you find the unit you have, which is in meters. You find them, so let's find it right here, since meters is our base unit. Right here, it's our 0. Find the unit you are changing to in centimeters. Okay. And count the number of units in between. I have 1 unit, 2 unit, right? And all I have to do is move the decimal point that many spaces in the same direction that I counted. So I started off with a base unit of 3, right? And so it's understood that I have a decimal point right there, 3.0, right? And so I moved it 1, 2 units. So I move my let me erase this really quick out of the way. And so I'm going to move my decimal point 1, 2 units. And so my answer is 300 centimeters. I don't have to figure out, I don't have to multiply, I don't have to do any of those things. I simply have to move a decimal point. Very simple. So let's try again, do a little practice. So let's practice moving 2,321.0 millimeters to meters. So I start at millimeters. Let's find that right here. Okay. And I'm moving to meters. So we need to count the number of units in between. 1, 2, 3. All right. So we have 2,321 millimeters to meters. I moved in this direction. And so I'm going to move my decimal point. 1, 2, 3. And so I should have 2.321 meters. And always remember, you have to put your units there. Let's try the next one. 521 grams to hectograms. Okay, so we're starting off right here, and we're moving here. And so we're moving 1, 2 spaces to the left. 521.0, 1, 2. So I should have 5.21 hectograms. 8.5 kiloliters to centiliters. So we're starting down here, kilo, and moving here. 1, 2, 3, 4, 5. Okay, so I have 8.5. So 1, 2, 3, 4, 5. My 5 there. 1, 2. 850,000 centiliters. Didn't have to memorize anything. All I had to do was move my decimal. Very easy. So I was correct. So things to remember, all measurements need a number and a unit. And the basic unit of measurements are meters, liters, and grams, and how to convert those metric units, which is simply moving your decimal point. And that's it for our tutorial today. As always, remember to like, share, and subscribe. And this is Mr. Hulsey signing out.